There's a gene sitting inside roughly 1 in 5 people on Earth that scientists can actually date. Not guess at, date, down to a window of roughly 10,000 years. It's one of the genetic variants most consistently linked to ADHD, and geneticists have found something almost nobody expects when they hear the word disorder. This gene didn't just survive natural selection by accident. It was actively favored by it. Something in it was worth keeping. And by the end of this video, you'll know exactly what. You've probably already heard the popular version of this idea. Hunters versus farmers. A DHD brain's built for the chase, trapped inside a world built for sitting still. It's a nice story. It's also mostly a metaphor, repeated by nearly every video that touches this topic. Almost never followed by an actual study. So we're not going to repeat it. We're going to go straight to the genetics, the field data, and the lab experiments that the metaphor was loosely based on in the first place. Some of what we find is going to support the idea. Some of it is going to complicate it in ways most creators conveniently leave out. Either way, you're going to walk away from this with something sturdier than a metaphor. Actual evidence, with actual dates, actual numbers, and actual names attached to it. Let's start with the gene itself. It's called DRD4, and it codes for a receptor that helps your brain respond to dopamine. One particular version of it, called the 7R variant, shows up again and again in people diagnosed with ADHD. Here's what almost never gets mentioned. Geneticists can actually trace the history of this specific variant, the same way you trace a family tree. By analyzing the surrounding DNA, researchers found that the 7R variant originated somewhere between 40 and 50,000 years ago, then increased rapidly in frequency afterward. That increase has a name in genetics: positive selection. It means this version of the gene wasn't neutral. It was actively helping the people who carried it survive and reproduce more often than the people who didn't. And the timing is not a coincidence. That window overlaps almost exactly with the major waves of modern humans expanding out of Africa into completely unfamiliar continents. Not the invention of farming, not settled villages. The exact opposite. The gene's rise tracks with movement into the unknown. Then, researchers went further. They studied 39 different populations around the world, over 2,300 people, and compared their DRD4 variants against their ancestors' migration history. The pattern was almost too clean. Populations with a long history of migrating farther distances carried a significantly higher proportion of the long DRD4 alleles, including the 7R variant. One statistical correlation from that research nearly hit the maximum possible strength a relationship like that can have. The more migratory the population's history, the more common the gene. So before we even get to behavior, the genetics alone are telling us something specific. This isn't a modern glitch. It's an ancient variant with a measurable date of origin and a measurable link to movement. Genetics can tell you a gene was selected for. It can't tell you exactly why, on its own. For that, researchers needed a population still living close to the lifestyle the gene may have evolved for. They found one in northern Kenya, the Ariaal, a population that includes both still nomadic herders and communities that have recently settled into permanent villages. Same ancestry, same starting gene pool, two very different environments. Researchers tested Ariaal men for the 7R variant, then measured something concrete: their nutritional status, body composition, fat-free mass, actual physical markers of how well fed and healthy they were. Among the nomadic men, those carrying the 7R variant were significantly better nourished than the men without it. Among the settled men, living in villages, farming, the exact same gene predicted the opposite. Worse nourishment than the men without it. Same gene, same population. Completely reversed outcome, depending entirely on which environment a person happened to be living in. Researchers proposed a specific reason. In a nomadic setting, without schools or fixed routines, the same restless, quickly shifting attention that struggles in a classroom might allow a person to track resources, threats, and opportunities across a constantly changing landscape far more effectively. This wasn't a survey. It wasn't a guess about ancient behavior. It was a measured, physical outcome in living people tied directly to whether their environment matched the trait or fought against it. Here's the part almost no other video on this topic tells you, because it makes the story less tidy. Researchers tried to replicate that Kenyan finding in a closely related population, the Rendille, this time studying children instead of adult men. They expected to find the same nutritional pattern. They didn't. In this replication, the 7R variant predicted something different. Household economic status, not the children's actual physical nutrition. That's not a failure of the theory. It's science actually doing its job, testing an appealing idea against new data and finding it's more complicated than the first study suggested. The honest version of this story isn't science proved ADHD is a survival superpower. It's closer to this. A specific gene shows real, repeated signs of ancient selection, and its real-world effects shift depending on economic and environmental context in ways researchers are still mapping out. That's a less satisfying headline. It's also the actual state of the evidence, and it's worth more than a clean story that oversimplifies it. So genetics gives us a when. Field studies give us a hint at why. Sometimes, for the actual mechanism, researchers had to build something more controlled. In 2024, a team designed a digital foraging task. Picture a simplified simulation of gathering resources from patches that slowly run dry, forcing a constant decision. Stay here and keep collecting a little less each time. Or move to a new, unknown patch that might be better or worse. This exact decision, in ecology, has a name. The explore-exploit trade-off, and it's considered one of the fundamental problems every foraging animal has to solve. Participants with more pronounced ADHD-type traits didn't perform worse overall. They achieved higher reward rates than other participants, largely because they left a depleting patch and moved on sooner than everyone else did. In other words, in an environment that rewarded switching, the trait that gets penalized in a classroom became a measurable advantage. A separate lab experiment pushed this further, using something closer to a slot machine with 6 arms, each with a different hidden payout rate. Adults with ADHD consistently chose options without the currently highest known payout, more often than adults without ADHD, trading a known smaller reward for a chance at new information. Then researchers gave half the group a common ADHD medication and repeated the task. The gap between the two groups shrank, which means this isn't just a personality quirk showing up in a lab. It's a dopamine-linked decision-making bias, specific enough that adjusting brain chemistry directly changed how much a person explored versus stuck with what they already knew. There's one more piece almost nobody covers, because it's less about finding resources and more about not becoming one. Some researchers have proposed a separate, less obvious explanation for why this trait might have been protective, not just better foraging, better defense. The theory goes like this. In a nomadic setting, being impulsive and behaviorally unpredictable might make a person harder to anticipate, harder to ambush, and harder to exploit by rival groups or opportunistic threats. Predictability in a dangerous environment can be a liability. A pattern a rival can learn is a pattern a rival can use against you. It's a smaller, more speculative piece of the puzzle than the foraging data. But it points at something the popular hunter story usually misses entirely. The advantage might not have only been about catching prey. It might have been about not becoming prey, in a social sense, to other people. One last thread, and it has nothing to do with survival directly. It has to do with who people paired off with. Researchers studying human pair bonding found a connection between carrying the 7R variant and patterns in a person's history of dating across different ancestries. It's tentative evidence, not a settled fact. But it raises a genuinely strange possibility. This gene may not have only shaped where ancient people were willing to go. It may have shaped who they were drawn to once they got there. A gene tied to movement, tied to exploration, and possibly tied to who you're willing to take a chance on. That's a very different picture than can't sit still in class. So here's the actual argument underneath all of this, stripped of the metaphor. If this trait offered zero survival benefit, evolution had tens of thousands of years and countless generations to quietly remove it from the gene pool. That's exactly how selection usually handles a costly trait with no upside. Instead, geneticists found the opposite: clear signs of positive selection, a specific window of origin, and a measurable link to the exact kind of unpredictable, high-movement environment early humans were adapting to. That doesn't mean ADHD is secretly a superpower with no real cost. The Kenyan data alone shows the same gene can help or hurt someone depending entirely on the world around them, which might be the most useful reframe of all. Not broken versus gifted, just a trait built for a specific kind of environment, one that rewarded switching, exploring, and reacting fast. Now living inside a world built almost entirely around the opposite. Scored against a classroom, it looks like a deficit. Scored against an unpredictable, resource-scarce landscape, the same wiring measurably kept people better fed, more adaptive, and possibly safer. The trait didn't change. The test did. And maybe that's worth remembering the next time this brain feels like it's working against you. It was built by tens of thousands of years of exactly the kind of world that no longer exists. And it was built that way on purpose.